This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on the law of sines. We're going to look at the law of sines for an AAS triangle. That means we're given two angles and a side, and the side is not necessarily between those two angles. Now here's our law of sines. Sine of angle A divided by side A equals sine of angle B divided by side B equals sine of angle C divided by side C. The thing to remember is little a is opposite big A. So if we're looking at this picture, big A is 40 degrees, little a is opposite it. Little a is 5. Big B is 62 degrees, little b is opposite. And little c is what we're going to look for, and it is opposite big C. So the sides are opposite the angles with the same letters. So we're going to take a look at sine 40 degrees, sine A over 5 equals sine 62 degrees, sine B over little b, and we're going to use this to solve for B. So of course B sine 40 equals 5 to sine 62, and then if we divide by sine 40 degrees, we get B is 5 sine 62 divided by sine 40. That is the exact answer. If you want to get an approximation, you'll need a calculator, and that comes up with 6.87. So that is the size of side B. We want to go ahead and find the size of little c, side C, as well as angle C. But you can recognize that angle C is not going to be terribly difficult because I have two angles already, and the three angles must add to 180 degrees. So knowing that if I have 40 and 62, those total 102 degrees, what is angle C going to be then? Of course, 78. 102 plus 78 would give us 180 degrees. So once we know that angle C is 78 degrees, we can say then that sine 40 over 5, sine A over A, is sine 78, which is C over little c. Same way, C times sine 40 is 5 times sine 78. So the exact answer here for little c is 5 times sine 78 over 40 degrees. And of course, big C is 78 degrees. Approximated value for little c is 7.61. So our next example is an ASA triangle, but the reality is if you have AAS like our last example, you really have ASA because you get the third angle because the three angles have to add up to 180. So I just went ahead and gave you all three angles anyway. But we certainly have a side here, which is 20, and then we have angles on either side of it, so we have 20 between 12 degrees and 18 degrees. We're going to go ahead and use our strategy here. Sine A over A equals sine B over B equals sine C over C. Sine C, sine 150 over 20 we could use, this part we could use, and then we can use each of those to solve for the respective missing piece. So I want to solve for A, sine A, there's A, there's capital A, sine 12 degrees over little a, equals sine C, sine 150 degrees over little c, opposite of 20. And what do we get from there? Of course, sine 150 is the same as sine 30 in the second quadrant. Second quadrant sine is positive, sine of 30 is a half. And then, of course, 20 times sine 12 degrees is a times a half. So if we divide both sides by a half or multiply both sides by 2, we would get 40 times the sine of 12 degrees is little a. That is our exact answer, and our approximate answer is 8.32. So that enables us to solve for little a. We can also solve for little b using this part of the law of sines. Sine b over little b equals sine c over little c. Sine B, angle B, sine 18 degrees over little b is what we're looking for, equals sine 150 over 20. Then, of course, 20 times sine 18 is B times sine 150. And, of course, sine 150 is a half. And solving for B, we divide both sides by a half or multiply both sides by 2, and we get 40 sine 18 degrees is B. So we've solved for little a and little b. We have all three angles. We were given the original side C. We've completely solved this triangle. Approximate solution for B, we get B is approximately 12.36. So if you have two angles in a side or three angles in a side, law of sines is the strategy that you want to use. But if you have two sides in an angle, this SSA case, you may recall from geometry, could be ambiguous. The SSA case can cause us some problems. So let's take a look at what we have here. So I'm not drawing the triangle this time. I'm just giving you the value for little a, the value for little b, and the value for capital B. And what we would use here is sine big A over little a equals sine big B, sine 60 over little b over 7. So there's our formula. We know what sine 60 is. It's root 3 over 2. If that helps us, we certainly could use it. If we solve for sine A, though, 7 times sine A is 6 times sine 60. So sine A is 6 times sine 60, 6 times root 3 over 2 over 7, which is 3 root 3 over 7, or approximately 0.7423. So if that's the case, we have two possible answers. We have a first quadrant answer where sine of A is 0.7423. We'll get that with inverse sine. A could be the inverse sine of 0.7423, but we could also have a second quadrant angle, because if sine is positive, we also have a quadrant 2 solution. That's why this can be ambiguous. I don't believe it's in this case, because what we get is 47.9 degrees is the inverse sine of 0.7423. The quadrant 2 version of that is 180 minus 47.9. So another possibility is 132.1. But we have to throw it away. Here's 132.1, here's 60. If you add those together, it's 192.1. And we know that the total of the three angles in a triangle must add up to 180. So 192.1, adding two of them together, tells me that 132.1 is not an acceptable solution for this problem. And the only value for A that we have is 47.9. So now what do I have? Now I have two angles. I have angle B, which is 60, and I have angle A, which is 47.9. And you probably see where this is going to go next. Namely, C is 180 minus 60 minus 47.9, because the three angles have to add up to 180. So once that's the case, I have all three angles, and I have a side, actually two sides. We can go ahead and find our missing side, which is little c, by using the law of sines. And I have a choice. I could either have used sine A over A or sine B over B. But since B was not something I computed, that's a little safer to use. So we'll go with sine 60 over B over 7 is sine C, sine 72.1 over C. And then C times sine 60 is 7 times sine 72.1. Dividing both sides by sine 60, dividing both sides by root 3 over 2. What do we get? We get an approximate answer of 1.01. So we have all three sides, we have all three angles, and we have completely solved that SSA triangle that only had one solution. Now our next example is going to have more than one solution, I think. We have B is 10, we have C is 3, and capital C is 30 degrees. We need to use law of sines. We'll use this version. Sine B over little b equals sine C, sine 30 over little c, 3. That will enable us to solve for sine B, and then we can go ahead and figure out what that angle B might be. So indeed, sine B over B is sine C over C, sine B unknown, over little b10 equals sine 30 over 3. Sine 30 is a half. That's nice to know. Of course, 3 sine B is 10 sine 30. So 3 sine B is 10 times a half. 3 sine B is 5. So we have a problem here, don't we? So we don't have one solution. We don't have two solutions. We don't have any. Because if I divide both sides by 3, sine B is 5/3. 5/3 is not in the range of the sine function. Recall that the sine must always be between -1 and +1. So this has no solution. There's no way for us to construct a triangle that will work this way. And we say no solution for that. And I suggest that you try to draw a picture with B of 10, C of 3, and angle C of 30 degrees, and you may be able to convince yourself why that's impossible. Length C is just not long enough to touch the other side of the triangle. So here's another question for us. Again, I'm just going to give you three numbers. Little a is 10, little c is 6, and capital C is 33 degrees. So this time we're going to use sine A over A equals sine C over C. Plugging in those numbers, sine A we don't know, over little a is 10, sine C, sine 33, over little c is 6. And then 6 sine A is 10 sine 33. We've seen that on each problem, so I get sine A is 10 times sine 33 degrees divided by 6. So sine A is about 0.9077. But again, we have two possible answers. We have a quadrant 1 possible answer, and we have a quadrant 2 possible answer. The quadrant 1 possible answer is just the inverse sine of 0.9077. The quadrant 2 is 180 minus that. So what does that give us? Inverse sine of 0.9077 is 65.2. 180 minus that gives us 114.8. Well, 65.2 plus 33 is what? Is 98.2. So that still leaves us plenty of room to have a third angle. 114.8 plus 33 is 147.8. Again, we have enough left to have a third angle. So we have two possible triangles that work from this set of circumstances. So our first case is if A is 65.2, C is 63. Now what would B give us? The three angles must add up to 180. So 180 minus 65.2 minus 33. We would have angle B is 81.8. So we have all three angles in this case. We know A is 10 and C is 6, so we're missing little b, but we could go ahead and find that little b using law of sines. So I'll leave that to you as an exercise. But that's not our only case. Recall we had two possibilities for this angle A. Our next case is that A is 114.8, because again the sine of these two angles is the same. If A is 114.8 and C is 33, we're going to get angle B by taking 180 minus 114.8 minus 33 degrees to give us 32.2 degrees. We want to solve for little b. The way you would solve for little b is you would just go ahead and use the law of sines again. We know this, right? A is 10, C is 6, big C is 33. Now we have values for b, and it would be relatively easy for us to go ahead and find sine b by using that law of sines, using this kind of formula. Sine b, for example, in our first example, sine of 81.8 divided by little b is sine c, sine 33 degrees, divided by little c divided by 6, which is relatively easy to do. And for the second case, sine b, sine big B, sine 32.2 over little b, that's what we're looking for, is sine c, sine 33 degrees, divided by little c. And that will complete this lesson.